So now let's see how to, this is a simple neural network, and see here, this is enough. If you see, there we had only one neuron in the hidden layer, but if you see, we have layer of neurons. So it's S layer of neurons here. So number of neurons in the layer is S. It's not single. But in the previous example, you have seen only one thing, one summation here. But here we have so many neurons, which means that each neuron will get the input with the different weights. Okay, so here P1 is given to the first neuron with the weight W1, 1, and the same input is given to the second neuron with the weight W of 2, 1. Okay, so here 2, 1 is nothing but the 2, W of 2, 1. 2 represents the second neuron and 1 represents it's from the first input. And similarly, for what to say, the P1 input is also given to the last neuron. And in that case, the weight will be W of S, 1 because it's the last neuron, S the neuron, and the input is from P1. So which means that it is W of S, 1. And it's not mandatory that all the inputs should be given to all the neurons in the hidden layer. It depends, okay? And this will give an output here, N, N1, N2, N3. Each layer of neuron will give an output, N1, N2, Ns, and it is given to an activation function. And based on this activation function, you will get different classes. So which means that if you see here, A1, A2, As, which means that instead of one class, here we have S number of classes. So in the previous example, we have taken 3 families of flower, Setosa, Virginia, and one more flower, which means that you will have 3 classes. So based on the features, what we are giving here, the neural network will be trained and it will classify whether it belongs to class A1 or A2 or A3.